SwayamPrabha. Digital India. Educated India.
So, good morning students, welcome to the NPTEL course on architectural acoustics. We are in the week 6 and the second lecture of the week 6, that is the lecture number 27 is on Electro-Acoustics II. This is the second series of lecture on electroacoustics. So, if you remember in the first lecture on the electroacoustics, what we have discussed is the total 3 basic components of the system of electroacoustics and what are the basic parameter that is actually we deal with the electroacoustical systems. So, today the learning objective of this 27th lecture on architectural acoustics will be we actually need to differentiate within the application system of the electroacoustics, particularly focusing to the auditorium design or that kind of principles. And also we will apply those fundamentals of the electroacoustical parameter to some extent of the loudspeaker arrangement also. So, from this to learning objective, let us move forward. In the last lecture, we have seen that the directivity of the loudspeaker, which is essential as the loudspeaker are of various frequency behave differently and the throw is short for the low frequency sound and this throw of the loudspeaker is higher or the long for the high frequency sound. So, here in this PowerPoint presentation in this slide, what I have drawn is that I have kept a loudspeaker in the ceiling and just below that at a certain distance I have kept a the dB meter, that is sound recording dB meter, and suppose the reading is x and the x is almost suppose the 80 dB or so. So, this particular axis is called on axis or vertical axis, just below just 90 degree or the perpendicular to that particular center point of the loudspeaker to the any point below is the on axis or the vertical line. So, now if I move this loudspeaker in the left or maybe in the right side, I will definitely record some change in the reading in the dB meter and definitely the reading will be less than 80 dB. And let us move it further and now move away to this particular point and suppose at this particular point it is 74 dB, the record is 74 dB. So, there is a 6 dB decrease from the on axis point, and this line, if I draw a line from the again a center point of the loudspeaker to that particular point where I record it at 74 dB, is this inclined line is called the minus 6 dB off axis line. It can be again you can again do this sometimes some way you can go radially up or maybe in the radially up also in this the right hand side also. So, just to show these two type of axis off axis, I have one side I have drawn a flatter movement or the horizontal movement and another side I have drawn a circular movement. So, by virtue of this circular movement, suppose at this particular point again you record 74 dB, which was actually 80 dB at the on axis. So, again I can join these two line, the midpoint of the loudspeaker and this particular point, and that is also called minus 6 dB off axis. So, I can say why this particular area, this particular shaded area is called as within the zone of minus 6 dB off axis zone, and this is the potential sound coverage zone, and that is the coverage of a loudspeaker. So, the loudspeaker will be loudspeaker will be placed or arranged in a such a way that we will actually the effective area of the coverage of the loudspeaker we will deal with this particular length or a vertical cross section aerial point of view, this particular circular area. We will not going to there will be some sound of course, but this as it is away from the off axis minus 6 dB, we will not take care of that particular area into consideration of our loudspeaker arrangement design or layout design. So, there are two type of dispersion. One is called linear dispersion, where you go straight horizontal and get the 6 dB off axis line, and sometimes we go conical dispersion when you go the circular in left and right side and you got the minus 6 dB axis line. So, there are two type of dispersion possible, and as is this two dispersion in between these two lines of these two minus 6 dB axis inclined line, the angle that in between these two lines are called coverage angle, and it is represented by theta. So, this coverage angle is very important in the loudspeaker design or the arrangement of the loudspeaker design in any format of electroacoustical arrangement, and being an architect we must know some of the principle the design fundamentals of that. So, the next one is that suppose I am providing a loudspeaker in the ceiling. So, this is the ceiling and this is the floor level, and this circular line is that line where this is the conical dispersion line, and this is the listener plane. The listener plane, if I actually some sitting kind of a category, it is 4 feet, and if it is a standing kind of a listener category, then it is 5 feet. So, mostly it is sitting in case of the auditorium. So, we actually take as this height as a 1.2 meter or 4 feet, and in that there are lines of minus 6 dB lines. So, this is for the dispersion which is a linear dispersion lines, and this is for the conical dispersions lines. So, all these 4 dots of the yellow dots are minus 6 dB dots, one follow the linear and other follow the conical, and the central this red dot at 0 dB, because it is the on axis line, and this is a reference point of 0 dB, which is actually the one of the strength axis or the of the acoustical strength axis you can say. But this point if we extend towards this the listener's plane, then you can say these two blue dots are also available, which is tentatively is minus 12 dB. So, the difference is dB level from here to here, it is minus 12 dB or so. So, that can be also taken into account in some kind of overlapping scenarios. So, by virtue of this we can say that this if you go with a conical dispersion, this you will get two such angles. One is this angle which comes under the conical dispersion, this angle, and one is the triangular or the linear dispersion, which is this angle. So, it has actually both two type of coverage angle. So, one called the nominal coverage angle, which is higher, which is a conical dispersion kind of scenario, and one called the effective coverage angle, which comes from the linear kind of a scenario. So, if you take the effective coverage angle and design your system, you will be little bit of conservative side, and if it is a nominal kind of a coverage kind of angle, it will be kind of a non-conservative zone also. It is much more wider, much more economical in that sense. So, effective coverage angle, if you see, it is almost like 70 to 80% of the nominal coverage angle. Now, next is let us go to the speech transmission index, which is another fundamentals in the electroacoustics or any kind of acoustics, where it talks about the how a particular speech is actually go from the source to the listener, or maybe and during this particular travel or this particular movement, this particular sound may be going to decay down, and due to this decay, this speech which is from the listener to the particular from the source to the particular listener is weakened, and what will be the particular modulation of that particular speech when a listener actually hear that. So, it is for this particular analysis, it covers almost 7 octave, 125 to 800 hertz octave, and it has carried out in a very complex kind of a scenario, and it is given a kind of a range within 0 to 1. So, a speech transmission index or SIT will have these following points, which will actually encounter while they will devise this 0 to 1 this kind of index. What are those points? The source speech level, and that will be actually going to take care of the syllables, word and the sentence of a particular speech. Sound distortion if any, background noise if any, there are frequency, type and level of the background noise also. What are the background frequency of the background noise, types and level. The quality of the sound reproduced by the equipment, suppose there are some speech which is actually reproduced by the some equipment or the electroacoustical equipment, what is the quality of that particular sound. The presence of echoes and the reverberation in a particular field, and a psychoacoustical effect, that is another thing, that is how a particular person perceive a particular speech, whether he can understand the speech or she can understand the speech in a thoroughly or thorough manner, which probably not that much problematic if he and she is in the very first row, but that particular understanding of the speech may be a bit of problematic when he or she in the last row, because of the distance things are decay down, the syllables, the word and sentence are not very much proper in terms of hearing. So, based on this all 1, 2, 3, 4, 5, 6 parameters, and with a complex kind of a the calculations, provide a table or provide a chart where SIT starts from 0 to 1, and what is the low numbers SIT means it is bad or poor, and if it is a higher number of SIT is good or excellent. So, always it has been always it is desirable to have the SIT value more than 0.5 definitely, though it should be more fair towards the good also. Providing a very good or excellent kind of the SIT, sometimes it is difficult. So, the designer, the sound engineers and the designers actually keep the particular things, the SIT value very near to 0.6, around 0.6, 0.65 or so for their design of the speech or those kind of activity area like lecture room or conference room or so. Sound reinforced system design, and what are the requirement of that. Those are the requirement. We required a maximum and minimum sound level you have to check, and these two should not be very high, and that will give you a inequality or the non-uniformity. Just I have told about the speech intelligibility, that is the how a speech is going to be captured by a person in various points of the auditorium, and how it will actually behave and how it is going to give you that kind of understanding of the speech. Sound level deviation, which comes from the first point, the maxima minima of the sound level deviations or so. Localization of the sound source, sometimes because of the faulty character of the electroacoustics, there are some kind of a localization of the, there are some points where you get a very high level sound and which is also bothering, and maybe some other point that is a level of sound is very low, which is again give a problem of the speech intelligibility also. You cannot actually purely you enjoy the music or the speech. Localization of the sound source, that I have just covered, the elimination of the echoes and the noise. That is on of course, one of the issue that this particular system should eliminate all the echo and all the noise as concerned. And what are the systems? There are the sound systems, sound reinforced system. There are two. One called the central loudspeaker system, where a cluster of loudspeaker is located in a central place, and it is very near to the stage or very near to the actual speaker or the actual performer, and that gives you 100% or the maximum realization of the particular sound, because it comes from the very near to the point where the actual sources are located. So, it is a single cluster, a group of cluster which are very focused and centrally located in a particular auditorium. And the second one called a distributed speaker system, where it is distributed in a small area or maybe a distributed in a larger area of the hall or the auditorium, where in each distribution loudspeaker a low level amplification is made and it is captured or it is provide the sound reinforcement in a smaller area, and that gives a particular uniformity and that gives a particular the reinforcing the sound in a particular space. So, this particular PPT slide gives you a cross section of a cross section figure of a auditorium, and I am talking about the central systems now, where you see a loudspeaker cluster is actually placed on the top, at the top just above the stage. So, there is a the source directivity in the sense of that the performer and the loudspeaker are in almost same vertical level, and within that particular zone you can have a low frequency bass cabinet or maybe the high or mid frequency horn kind of a the loudspeaker. And from here we have to see the what is the coverage zone. We will discuss in details how to manage the coverage zone from the very first sitting audience to the last seat and maybe also in the balcony. You also has to see the under balcony situation. Sometimes this under balcony is not going to receive the sound from this cluster, and we have to see the what is the height of the installation. As the height of the installation is high, your distribution potential is also going to be high. So, this height is one of the character or the one of the basic design parameter of the whether you are going to use a central system or not. That is one of the height is the one of the design parameter. So, if I take a stage elevation point of view, so this cluster of the arrays of the loudspeaker is placed at the central part of the stage, the above the stage, where there are some low bass and some directional kind of a mid or high frequency sound loudspeaker, and sometimes there are some column loudspeaker are also placed in the sides, which is required for the some kind of a side fill. So, now let us consider why in the central system you require a huge amount of volume or huge amount of height. Suppose if you see this particular cross section, where a particular cluster, from that if I draw a straight line to the first audience and also the last audience, and this, if we measure this x and y, if the y is twice of x or something like that, or more than twice of that, or maybe the y by x ratio is more than less than equal to 2, then it gives you a consistent kind of a coverage, where the x is the shorter distance, the first row distance from the cluster, the central cluster, and y is the last row distance from that cluster. But if I reduce the height of the auditorium and I place the same cluster, then I will, if I draw the line x and y, I will get two different dimension, and there probably this y by x will be greater than 2. So, the x will be smaller and the y will be larger and this ratio will be greater than 2, and if it is greater than 2, then it will give you a very inconsistent kind of a coverage. So, better not to go with the central type of system when the auditorium ceiling is low or there is this x by y by x is greater than 2 kind of a scenario. We can just draw two simple lines in our sectional drawing in AutoCAD or maybe any kind of a the software, and check the what is the dimension between ratio of the dimension y and x, and then you can decide that this particular systems can be applicable or not. Sometimes may not be for, suppose the auditorium is quite a large, or the height of the auditorium is large, but because of the placement of the false ceiling, the apparent height of the auditorium is bit low, it come down to a bit low, and then we can say that this x by y ratio may not be adequate, may not be give you a consistent kind of a coverage. So, the enough volume and the room height, so the y by x ratio should be less than 2, otherwise there will be a problem, kind of the consistency problem, and audience should have a line of sight to the speaker cluster. So, the audience, the last audience here should see that if he or she can see the cluster, there is a direct sound can become and propagate from that point to the last row. So, as I told, a particular cluster of speaker or maybe a particular line of cluster of speaker may not be sufficient to cover the entire area. So, you need some kind of downfall kind of a speaker. So, a downfall speaker is another cluster which is given in some different angular orientation, and that will going to cover or the in the some other part or the maybe the front or maybe the rear part of the auditorium and the seating. So, maybe one or two such downfill the speakers can require to cover the entire zone from the point of view of the clustered or the central distribution system. Sometimes in that kind of a consistency, to provide some kind of a consistency in the larger auditorium, when the auditorium is very large, the rows of speakers are provided like this, the array, the line array is provided like that. So, it is not one or a particular, it is a kind of a, you may say that a particular clustering systems, the central systems now gradually move from the central cluster system to the distributed system, but the principle adopted here is central cluster, because it is started from the very top and it is focusing towards the various part of the auditorium in a spatial directivity and the sound reinforcement principles point of view. So, in nutshell, what we can say that the coverage and the particular aerial the distribution of the sound from the vertical point of view is very important. So, let us talk about the horizontal coverage. This is a plan of a stage and there are the audience. I have placed two such loudspeaker in these two very uniform points or the symmetrical points, and it gives a uniform distribution. Sometimes, if the size is larger, then we can go with some kind of infill or some kind of overlapping scenarios. And if you go for those kind of overlapping scenarios, those two red color zones, of course, this red color zones a little larger than the circular, are come under a typical overlapping scenario. And this typical overlapping scenario are actually create some kind of sometimes it may create kind of a hot spot. So, the power output from this has to be little low with compared to this two to create or minimize that particular kind of a hot spot. That is one. And number two, sometimes it is essential to go some additional kind of a loudspeaker, because if I say this is a wide type of a auditorium where there are aisles and there are seatings like this. So, there are some area where actually this particular two cannot be adequate. So, there are some areas here it is a deep. So, this area the back benchers or the back seaters are not adequately taken into the sound reinforcement category or the sound reinforcement atmosphere. So, you need some kind of a speakers which is in the sides, which is in the wall mounted, which will going to take care of your those area where you have not taken attention from the central cluster. So, those are called the fill-in loudspeaker. So, those fill-in loudspeaker are also go along with your the central loudspeaker system, where there is a requirement of filling if the loudspeaker or the central loudspeaker are not adequate to cover the entire wide or the entire deep zone of your audience. So, now let us see the what are the possibilities. The possibilities are the main cluster is definitely is the important one, because this is the actual backbone or the actual fundamental need of a central system, but you require some kind of a side fill Why side field? Because sometimes the audience are in a larger or the wider the spectra. So, the left and the right side of the corner or the wall side audience should have equality from the particular the sound reinforcement system point of view, you require side field, that just now we have discussed in the last slide. And then this is also may not be adequate, you have to go now rear part, and the rear part you may require a special attention from the balcony. Of course, you have to give another cluster in the balcony just to take care of the balcony. You have to see the what is the sound level here and the what will be the actual output sound level here with respect to this, because sometimes if these two are mismatch, there will be some kind of a hearing confusion over this particular people who are there in the balcony, and there may be some kind of a strengthening point or the loudspeaker has to be provided the below balcony area, because it is sometimes seen or many times it has been noticed that this central cluster cannot reinforce the sound below the balcony. So, in nutshell what happened is that we have two layers, one side field and the main layer for the front and the mid zone of the people, and one is for the balcony or the rear part of the people. So, next let us go to the second type of system, which is called distributed system, where I have drawn a sectional view of a particular auditorium which is low, the ceiling is very low. So, a central cluster can give you this x and y mismatch, the y by x ratio is more than 2. So, it is better to go for a distributed system. So, ceiling mounted things or maybe the wall mounted things will be provided, and this will be given some kind of individual coverage of the speakers, and we have to check that total coverage of the speakers and all those are in a particular way that it gives a uniformity all over. Again, height of installation is one of the major parameter to design this particular system. The pattern and the distribution system is important, and for this particular selection method and any kind of a criteria, and what are those criteria for the selection methods and design of any loudspeaker are speaker coverage angle and its effectiveness, sound level capability of the system, sound and speech intelligibility, the power amplification quality, and of course, the cost of the system. So, we will discuss about how the speaker can be arranged in a distributed system. So, we have just now completed the two type of systems, that is distributed and the central, and now let us again discuss about the dispersion, which is the conical dispersion and the linear dispersion, which we were discussed in the 26th lecture. And the listening height I have told you, that is 4 feet for the sitting, which is 1.2 meter. So, this height they float to a height of our ear, standard ear, and 5 feet for standing or 1.5 meter for the standing. So, there are two type of pattern possible, one is a square kind of a pattern and one is hexagon. In the square pattern, it is very easy, and square pattern is that it is very easy to lay out the square pattern, because it is in squares and it is placed in the equal grids of a square. And the easiest part of it, that if some kind of a strengthening is required in some localized zone, or the zoning is very easier in case of this the square pattern kind of a the distributed system. It gives you almost even kind of a coverage with less number of speaker, which is economical, and usually this is the starting point of any kind of the coverage for a distributed system, and also it is preferred choice. So, there are different way I can cover it up. So, if these black dots are the speaker points in the top, and these circles are the coverage at the particular the listener level. So, if I placed it so closed, and it is called the minimum overlap. Now, If I just move it a bit, then it is called the minimum that was the maximum overlap, sorry, and this is called the minimum overlap. And there are third type of overlap also possible, which is called edge to edge overlap. So, if we see in the minimum case, maximum case, this area there is a possibility of a hotspot, and the speaker spacing is equal to r. R is the radius of this coverage at the listener level. Here in the edge to edge, there is a potential area which is not taken into account or that not considered at all, which definitely gives a cold spot or a drop of sound level, and where this distance between the speaker to speaker is r plus r equal to 2 r. In case of a minimum overlap, this distance is in between r and 2 r, something like 1.5 r or 1.75 r, something like that. Let us go to the next slide and see sometimes this edge to edge overlap is also go into different extension. There are possibilities of 1.5 times edge to edge, that means this length is 1.5 times of this 1.4 times of this length, sorry, and 2 times of edge to edge is that this length or the distance or the spacing of the speakers are 2 times of the spacing of the speaker, which compared to the edge to edge. So, those are the square patterns. Now, let us discuss about the hexagonal patterns. In the hexagonal patterns, the rows of a specific line and the next rows are having some kind of a offset with the other, and in hexagonal spacings or the pattern, you required more number of loudspeaker, but some pattern like a square pattern of the loudspeaker system, in some end rows or in the edge areas, there may be some kind of a coverage problem. Then sometimes we have to go with a hexagonal pattern in those area, where because some portion may be unattentive in that case, or sometimes is this hexagonal pattern also sometimes economical when we deal with some non-rectangular space of suppose a circular auditorium or maybe a trapezoidal shape of or octagonal shape of some the lecture hall or something like that. So, all those area a square pattern or the layout may not be economical, hexagonal will be economical. So, there are some hexagonal clustering also. So, if it is very close like those, again black points are the speaker points and this circular are the coverage, potential coverage circular area on the listening level. So, it can be a minimum overlap and the distance between them may be r, and there may be a maximum overlap. So, there are overlap, but there is a little bit of way the spacing are little bit of away with respect to the maximum, and there may be edge to edge kind of a overlap like that, and this particular the unattentive area with compared to the square is little less, it is triangular, in that case it was square, and this the center to center distance is now become twice of r, and in this case of the minimum overlap it is in between. So, we can design also. So, if I just say this r I have to find out which is what is r, this is the radius of the coverage circle at the listener height. So, if I know this L, this is the listening height which is 4 feet or something like that, and this is the mounting height. So, I know this is as h minus L, and this angle is theta by 2, and this is my r. So, with a very simple trigonometric functions I can use and I can find out this r equal to this h by L times tan theta by 2. I can found the r, and if I can found the r, I can found the spacings also, I can found the all the spacings also, if just to you have to know the value of r. So, if it is a comparison table and for the squares and the hexagonal, these are the overlap type maximum minimum edge to edge 1.4 and 2 times edge to edge. So, those are the the increase in SPL level for a single speaker, suppose you go for a single speaker and if you go for a edge to edge or maximum levels or so, what are the increment? So, the for a maximum definitely the increment is very high, because there are a lot of overlapping. If the minimum overlap from the single loudspeaker, this particular the increase is little less, and if you go for 2 edge to edge, 2 times edge to edge, it is almost like a single loudspeaker, because it is the increment is 0.2 dB. In case of the hexagonal, the maximum is almost plus 5.4 dB with respect to a single, and if you go to 2 times the edge to edge, it is 0.3 dB, as good as the single loudspeaker system. And in the SPL variation is that what is the maximum SPL and the minimum SPL. If you go for a square and the maximum overlap, it is minus 1.4. So, it is almost uniform, and then if you go for a minimum and all, the SPL variation is actually increasing, the variation is increasing. So, these 3 are good enough, these 3 are almost good enough. You have to actually see the SPL variation should not be more than 6 dB. That create a kind of a sound problem, the ununiformity sound problems or so. So, from that point of view, the first 3 of the square and the first 3 of the hexagon gives you a better type of uniformity, which are below 6 dB level. So, these are the comparison between the square and hexagon and the sound pressure level. And in the final, let us talk about some 3 defects which encountered in the electroacoustical systems. One is called cross firing. So, if you provide the source of the sound just next to next or the opposite in wall, and the receiver is actually at the center point, it is actually a confusion of the hearing called cross firing. So, it is better to provide these systems not in face to face or directly at the opposite, it has to be some kind of a oblique. Sometimes a sound delays also occur. So, as I discussed that there are some kind of a PS is the primary source, and this is the secondary source will be available from that. The distance is quite huge. So, you will receive this particular receiver will receive the sound in a delayed manner, little bit of delay, and confusion of the hearing will be occur. So, you have to check the distances, or you have to decrease or increase the sound pressure level that do not create that kind of a hearing problem. In open air or maybe in kind of some kind of a announcement system, this distance is also very important, because suppose a particular listener listens a particular announcement from this particular PS, the primary source at a distance d1 and a secondary source next to d2, and if this d2 minus d1 this path difference is too high, it may encounter a artificial echo, or it can create a confusion of the hearing, particularly in the railway station, in the airport, or maybe in the any public gatherings, any political rally. This kind of the situation may happen. So, sometimes in the railway stations we also kind of eagerly waiting for some kind of a announcement has to be made for some railway, some train, and there are some some confusion because of this particular fundamental problem, where D2 is quite high compared to D1 and you are receiving sound from both. So, the sound comes from D1 reaches you early and sound comes from D2 or SS is reaches little late, and little late means it is not, it is more than 1/10 of a second late, and those two sound are merging with each other in a time lag, create a artificial echo or those kind of a problem. So, that is all for the particular lecture number 27, which deals with the acoustical principles and its the relation with the systems of acoustics, electroacoustics. So, let us have some homework. Let us have some homework for your understanding and how you actually learn this particular 2 lectures and comprehend that through this particular homework. Let us discuss that. Let us first one is the something like the theoretical kind of a thing. Let us differentiate between the the cluster system and the distributed system, what are the basic need and what are the basic parameters of these two type of system, and what are the clustering of the systems has any difference, where in case of the central cluster and in case of the distributed pattern of the loudspeaker. That you have to discuss in the first, and in the second one I have given some loudspeaker fundamental properties, like 60 degree is the coverage angle, and it is suppose 1.4 times h to h kind of hexagonal pattern, and speaker is mounted at a height of 12 feet, and can you find out the spacing of the loudspeaker with a seating kind of a scenario. So, let us try this too, and these are the some of the books which I have referred, and that is all for the lecture number 27, electroacoustics. In the next lectures in this particular week, Dr. Shumuna Gupta will take you to the outdoor acoustics in the landscape, how it is actually going to affect the outdoor, and also the OAT, that is open air theatre design, in the remaining 3 lectures of the week 6. So, thank you very much for joining this lecture.